Today we'll talk about the parabola. The parabola is created when you take a cone and slice it with a plane as such, creating this parabolic shape right here. We see it all over the place. The unfortunate association with our culture here in the States. Beautiful gateway arches. And even a typical water fountain. Just as a friendly reminder, recall from our parametric unit, we were talking about, let me just draw this here. Oops, sorry about that. When you have the initial height equal to where your thing is landing, our thing in this case is water, well, the distance it takes to go up, it will take the same amount of time to go down. And if you just think about it, that makes a lot of sense, because if that weren't the case, if it was going up faster, well, we'd have a heck of a lot of water building up right there. Or if it fell faster, well, we would have a huge gap right there, say. Something to think about. Now for the main features of a parabola. Okay, we have the vertex. The vertex is that point where the axis of symmetry cuts right through. The vertex is also the midpoint between what's known as the focus and the directrix. Okay, so right here is your focus and your directrix. So if I say that's the midpoint, well then this and this are equivalent, congruent. And we're going to call that distance P. Well, technically P is the distance between the vertex and the focus. Okay, and I have that written right here. This is important. When we refer to P with the parabola, that is going to be the distance from the vertex to the focus. Okay, so just if we were to have the opposite type of parabola facing that way and our directrix was here and our focus was right there, well then, because I'm going from the vertex to the focus downward in a negative direction, that would have a value of negative P. Okay? Alright. So let's move that there. Back to here. We're going to be talking about the equations momentarily. When we are referring to those, the HK... Oh, that's not too easy to read. The vertex will be known as HK when we get to those equations in a minute. Okay? Now, there's something... If you recall from geometry, just a quick little reminder, if you have any shape... Let me just draw that. A chord touches one side and touches the other side, but doesn't extend further. So with a parabola, if we have a chord that goes through the focus, well, then we can call that a focal chord. Okay, if it's a chord that cuts through the focus, it's known as a focal chord. Focal chord is a chord passing through the focus. Now, there's a special focal chord that's of interest to us, and that has a name of the latus rectum. It is perpendicular to the axis of symmetry. Okay, that's the key feature, the key difference between any random focal chord and the latus rectum. Okay, so if you notice, this red line right here, okay, this red line right here, that is this latus rectum word right here. It is a chord. It goes from this side to this side, and it cuts right through the focus. Okay. Now, the distance of the latus rectum is 4p, but why is it 4p? Well, if you notice right here, we said that this distance right here is p units. Okay, well, this distance right here is also p units, and this distance right here is also p units. So the distance between the focus and that side of the parabola, we can call 2p. Well, the same thing on the other side. This is p units, and this is also p units, so this distance is also 2p. 2p plus 2p would give you 4p. Okay. This is important. The distance is going to be coming. You're going to see that again. You will be asked, what is the distance of a latus rectum? You need to know Once you find p, you multiply it by 4. Okay. Recall from geometry. Okay, I have some random parabolas here. When you have a parabola facing upward, we have ourselves an x squared parabola, and this is also an x squared parabola, but you remember that from geometry as a negative x squared parabola. Well, technically, the way the negative comes from is it's an x squared parabola with a p-value that happens to be negative. Okay. This is an x squared parabola where the p-value is positive. Okay. And if you recall, these are your y squared parabolas. This is your y squared parabola when your p has a positive value. And this is your parabola when your p has a negative value. Okay, so once you figure out the p-value, which we'll do in a second, you'll know which way your parabola is facing. So the standard form of the equations of a parabola are right here. Okay, depending on which way it's facing. So if you have a y squared parabola, well then obviously your y has to be the squared value. And recall the hk is your vertex. The h always goes with the x and the k always goes with the y. And you have to multiply that by the lattice rectum, which we said was 4p. If your parabola is facing this way, if you have an x squared parabola, well then clearly your x value has to be the squared one. And again, the h goes with the x and the k goes with the y. You multiply that value by the lattice rectum, 4p. The general form of the equation of a parabola, very similar to the circle. The only real difference is you only have one squared term, not two. So you're either going to have your x squared or your y squared, but you're still going to have a x term with a coefficient, a y term with a coefficient, and a constant set equal to 0. I want to just review that diagram we looked at earlier. I just want to clarify that p-value. Let me make that bigger there. All right, so there we go. If this is my vertex, and I told you that the p-value is going from the vertex to the focus. Okay, now the focus is always inside the parabola. Well, if I'm going up, that means I'm adding a value, which gives me a positive p-value, versus if right here is my vertex, well, then my focus is going to be there because it's always inside the parabola. Well, then that means that my p-value is negative. I have to subtract to get down there. Okay, and therefore you have a negative p-value. You follow the same pattern for the x squareds and the 2x squared parabolas. Okay? All right, now let's do this problem. We're going to find the coordinates of the focus and vertex and the equations for the directrix and the axis of symmetry. Key, everyone, many times people confuse that and just give me a coordinate. It is an equation, it is a line, the directrix. Okay? Let's do it for this parabola right here. Okay, so we have x squared plus 4y plus 2x minus 3 equals 0. Well, what are we going to do? We're going to do what we did with the circle. We're going to complete the square, and that will give us the information we need. So, if you don't recall, we're going to get whatever's squared on one side. Here we only have an x squared term, so let's get the x's on one side. We'll be adding something there. I'm going to move everything else over. Okay, I'm going to move that over, and we're going to move that over, which is going to give us a negative 4y plus a 3. Let's complete the square over here. If right here my b coefficient is 2, so half of b goes there, so half of 2 is 1, positive 1. When you square it, you still get 1, so I have to add 1 there. Remember, this is an equation, so if we're adding it to the left, add it to the right, which is going to give us negative 4y plus 4. All right, now let me just change this here. The standard form looks like this. We have x minus h squared equals 4p y minus k. If you notice, that y coefficient is 1. I got to make that y coefficient 1, so how do we do it? We take out whatever we need to make that 1. So in this case, we need to take out a negative 4. So that's going to give us x plus 1 squared equals a negative 4 y minus 1. If you want to just check yourself real quick, distribute. Negative 4 times y gives you negative 4y, and a negative 4 times a negative 1 does give you a positive 4. All right, so now we can at least tell you the vertex. The vertex is hk, so the vertex is going to be, let me write that down. What do we got? Negative 1 comma 1. And now for the focus, in order to figure out the focus, we need to know what P is. Now let's figure out what P is. Now right here, notice that 4P equals negative 4. All right, let's use that. 4P equals negative 4, which means that P is going to equal negative 1. All right, now we have a negative p with an x squared. I know which way my parabola is facing. It's going to be facing downward. Okay, and let me move this off here. Okay, we know p is negative 1. So let's identify the vertex and figure out the focus now. So the vertex is negative 1, 1. So negative 1, 1 right there. There's our vertex. The focus is negative 1 units away, so I have to subtract 1 to get to it, which is going to put the focus right there at negative 1 comma 0. There's my focus. Just so it's been said, this is the vertex. All right, so what else do we have to find? The directrix. Well, the directrix is, remember, the vertex is the midpoint between the focus and the directrix. So that means that if the focus is p units away, so is the directrix in the other direction. But the directrix is not a coordinate. It is not just that point right there. It is the entire line. That entire line is y equals 2. Okay? This is your directrix right here, y equals 2. The axis of symmetry. The axis of symmetry cuts right through the vertex, and it is cutting through x equals negative 1, so therefore our axis of symmetry is x equals negative 1. Let's take a look at your outline now. Today we discussed the parabola, so be prepared to come to class, and we're going to work on page 540, those problems right there.